Hello and welcome to a new video on indices. Okay, so in this video we'll be talking on solving exponential or indical equations. So your exponential or indical equations are equations that take advantage of the concept of indices, right? So in order to solve for your unknown. So we are going to be solving some of these questions. We are going to apply the laws of indices that we learned over the course of this topic, and then we'll be using it to solve these problems. So the first one says, the example says solve the following. So A says 3 to the power of x equals 9. B says 16 to the power of x equals 8. C says 9 to the power of 4x equals 81. D says 4 to the power of minus 3x equals 1 over 64. And E says 3 to the power of 2x minus 2 equals 9 to the power of 2. So that's the basic idea. We want to apply the law of indices to solve these questions. So what's the general idea here of solving these questions? So you want to make sure that both sides of your equation have the same base, right? You are expressing them in the same base so that you can apply some similarity between them to break down the question. So these are all equations that are based on the laws of indices. We call them the exponential or indical equations. So let's try to solve them. Let's start from the first page. So the first one says 3 to the power of x is equal to 9. So in order for you to get through with this one, you want to write both your left hand side and the right hand side to be based on the same base. So it is easier for me to express 9 in terms of 3. So we could say something like 3 to the power of x is equal to 9, which is the same as 3 to the power of 2. So now this idea is telling us that if 3 to the power of x is the same as 3 to the power of 2, we could have it to say that our x is equals to 2. If this is equals to this, then this is equals to this. That's the idea being communicated. 3 to the power of x is equal to 3 to the power of 2. Then x and 2 are the same. So that is the general idea here. So that's solved about the first question. So we can call that equating the indices, right? We equated the indices. We made the powers equal. Index refers to the power. So also in some literature, in some textbook, you may have something written like this. You may have that 3 to the power of x is equals to 3 to the power of 2. And they may do things like this so that you can visualize that that your x is equals to 2. And they will say something like x, 3 cancels 3 and x is equals to 2. So now this line per se is not really it's not really what we do in mathematics. It's not quite valid. It's not really something that we do. But just because it works does not mean that it's basically very, very valid. Or just because it is very valid, it is not quite valid doesn't mean we cannot borrow from the idea, if that's what allows us to understand the concept well. So the idea being communicated is that we equate the indices, since the idea is that the powers, the bases are the same. So if we have, say, the same basis, we can always equate the powers. So that's the idea. So let's move on to the next question. So the next one says, the B says what? 16 to the power of x is equal to 8. So we have the same idea here. So what do? We kind of break the left hand side and the right hand side to the same base. So I cannot say 8 to the power of anything will give me 16, and I cannot say 16 to the power of anything will give me 8. But it looks like I can break both of them in terms of 2. I can say 2 to the power of 4 is 16, and I can say 2 to the power of 3 will give me 8. So I can use it to break both of them down. I can take advantage of that. I can say 2 to the power of 4 is 16. That's 4 times x will give me 4x, and is equals to 2 to the power of 3, which is 8. So I have it that 4x is equals to 3, and divide by 4, the x is equals to 3 over 4. So I can make my x alone. So x is 3 over 4 in that case. Okay, so moving on, we have it that 9 to the power of 4x is equals to 81. So as well, I need to make everything on the left hand side and the right hand side be consistently the same base. So I can say, okay, I can make everything in terms of 3, or I could make everything in terms of 9. Since this is 9, I can express 81 in terms of 9, then that's fine. So I can say 9 to the power of 4x is equal to 9 to the power of 2. Since we have the same base on the left hand side and on the right hand side, we can say something like 4x is equals to 2. Okay, we can equate the indices. So what we did here is equating the indices. Now we can divide by 4 and divide by 4 to solve for x. 4 cut 4, and we have x is equals to 2 over 4, which 2 here 1 and 2 here 2. We have it to be 1 over 2. Okay, so that's that there. So let's take the fourth question. The fourth question says 4 raised to the power of minus 4 raised to the power of minus 3x equals 1 over 64. So let's go on from there. So we have D to say 4 to the power of minus 3x is equals to what do we have? 1 over 64. 1 over 64. Okay, so recall that we can write 1 over 64 as 64 to the power of minus 1, since it is we have it to be a 1 over situation going here. So we can say this is 4 raised to the power of minus 3x is equals to 64 raised to the power of minus 1. Now I can break things down. I can express both left hand side and right hand side in terms of 4. I can say that 64 is 4 to the power of 3, because 4 times 4 times 4, 4 times 4 times 4 is 64. So that's 4 to the power of 3 is 64. And I have that to be 4 to the power of minus 3x equals to 4 raised to the power of 3. So that 3 will multiply by the minus 1 to give you minus 3. So it turns out that 4 raised to the power of minus 3x is equals to 4 raised to the power of minus 3. So since the bases are the same, we can equate the indices to say minus 3x equals minus 3. So you divide by minus 3 and divide by minus 3, your x is equals to 1. So that's the idea. And we have question E. And what is question E? We have it to be 3 raised to the power of 2x minus 2 equals to 9 to the power of 2. Okay, I need to express both the left hand side and the right hand side in terms of the same base. And how do I do that? I can say 3 to the power of 2x minus 2 equals 3 to the power of 2 will give me 9. So I can say 3 raised to the power of 2x minus 2 equals to 3 to the power of 2 is 9. That 2 must multiply by this 2, which is here, to become that. So 3 raised to the power of 2 is 9, but this 2 that was existing there. So now the bases are the same, right? So we could easily write that 2x minus 2 is equals to 2 times 2 is a 4. So we have it to be that's 4. So if we collect like terms, you can say 2x is equals to 4 plus 2, and 2x is equals to 6. If we divide both sides by 2, then x is equals to 3. And that's what we have for that. So we have successfully solved some sets of indical equations. We went all the way from saying 3 raised to the power of x equals 9, 16 to the power of x equals 8, 9 to the power of 4x equals 81. 4x power minus 3x equals 1 over 64. And the last one, which says 3 raised to the power of 2x minus 2 equals to 9 squared. So that's what we have, and that is what we went through in all 5 questions we did. So I hope that is quite clear, and you can catch up in the next class as well, in the next video.